Today we're going to start on lesson 11 problem set that is all about modeling division as the unknown factor in multiplication using arrays and tape diagrams. So we haven't really used tape diagrams a whole lot lately, so I'm excited to get to use those again. Let's go ahead and get started with problem number 1. Mrs. Prescott has 12 oranges. She puts 2 oranges in each bag. How many bags does she have? Well, first part A is asking us to draw an array where each column shows a bag of oranges. So first we need to think about which way does a column go. Well, if you row your boat, hopefully you remember that rows go this way. And that L in column helps us remember that columns go up and down. So I'm going to change my pen size to almost the biggest size so I can draw my array. Each column is a bag, and she puts 2 oranges in each bag. So let's go ahead and draw our array. Alright, so I know I need 2 oranges in each bag. So I'm going to kind of go backwards to the way I normally would draw my arrays, because instead of my groups being my rows like they normally are, my groups are actually going to be my columns. So I have 2 oranges in my first bag. 4, 6, 8, 10, 12. Okay, so hopefully that wasn't confusing. Remember, normally my rows go this way and my rows are normally my groups. In this instance, because it's telling me something different, my groups are actually going up and down because my groups are my columns. Okay, so I have 2 oranges in each bag. So here's a bag, 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 bag. Alright, so let's do our division sentence. Remember, in division I always start with my total. So how many oranges did we have? 12 oranges. And then 2 oranges in each bag is my divided by 2. How many bags did we end up using? 1, 2, 3, 4, 5, 6 bags. Okay, and I'm going to swap my pen size out there. There we go. Okay, now I'm going to do the same problem in another way using a tape diagram. So we're going to redraw the oranges in each bag as a unit in the tape diagram. The first one is done for us, so we can use that example to keep going. And it says, as we draw, we need to label the tape diagram with known and unknown information from the problem. So let's go ahead and just fill out our tape diagram. I'm going to make it a little bit bigger so I can write in it nicely. And I'm going to pick maybe the third to last pen size. Okay, so I know I need 2 oranges in each bag. So I'm going to go ahead and do just what my first picture did. And I have 2 oranges, so I did the same thing in the other boxes. Now, I see my little bracket here that's showing me just this first box. Well, I'm going to write in this empty space here what this box represents. Just that box, because that's all my bracket is pointing to. So, what does that box represent? Well, I know that there are 2 oranges and that this box is 1 bag. So it actually has 2 different meanings, and I'm going to write both of those meanings. So it is 2 oranges and it is 1 bag. So maybe I can try to put a little slash, 1 bag. Okay. And it's kind of hard to, write everything in that small box. So if you go outside of the box, obviously that's okay. Alright, so our next bracket, you can see it stretches the whole entire length of our tape diagram. And it's got that little notch that points down to this empty box here. So I want to know for this one what this whole entire tape diagram represents. So again, we can say it in the context of oranges and in bags of oranges. So first, how many oranges are there? Well, there are 12 oranges. Or it could also mean 6 bags, because there are 6 bags of oranges. So it has a couple of different meanings depending on how we look at it. All right. Mrs. Prescott arranges 18 plums into 6 bags. How many plums are in each bag? Model the problem with both an array and a labeled tape diagram. Show each column as the number of plums in each bag. So we're doing the exact same thing that we did up here for parts A and B, except it's not divided into parts A and B. We just have to do both parts in the same workspace. That's all. So let's work on our array first. Okay, so we really need to think hard about which number is going to go where. So I'm either going to have 6 rows or I'm going to have 6 in each row. Now I know that I have 6 bags and that there are some plums in each bag. I don't know how many yet. But I know that my columns, or up and down, need to be the number of plums that are in each bag. So if the size has to go this way, then that means my number of bags or my groups have to go this way. And what that means is I actually have to make my dots going in that direction. So let's go ahead and start by doing a row of 6, because each one of these dots is going to be a bag. Okay? Because there's going to be so many in each bag. Now normally I would say that this way is my bag because of my groups, but when it tells me specifically what needs to represent what, that's what I have to do for my problem. Okay, so the number of plums in each bag is my column. If I had 6 going this way, then that would be 6 in each bag, and that's not what my problem's telling me. So I had to kind of flip-flop it. So I'm going to make another row of 6, and now I have 6 plus 6, which is 12. 13, 14, 15, 16, 17, 18. So there's 18 plums that are in 6 bags. Remember, I know it doesn't look like 6 bags. It looks like 3 bags because we're used to our rows being our groups. But our columns are actually our groups of 3 this time. All right, I'm going to triple tap and make this smaller because I need to fit my tape diagram on my page, and I know that my tape diagram normally takes up a lot of space. So I'm trying really hard, and it is hard to move these dots, let me tell you. There we go. So I'm trying really hard to get those moved around and lined up on my page. If you don't have as much luck either, then that's okay. It could be easier to move your paper too and not your array. But there we go. I got it shrunk down to size. So now I'm going to do my tape diagram. First step in a tape diagram is to draw my rectangle. And I like to make my rectangle pretty big so I can fit everything I need to. And then I'm going to kind of move it down a little bit because I didn't leave room for my top bracket. Okay, so now what I'm going to do is I need to draw my sections of my tape diagram. Now, each one of my sections is a group, and I know that I have 6 bags. So I need, how many lines will make 6 pieces? Well, remember that the trick is whatever number of pieces you need, you draw 1 less line. So if I need 6 pieces, I'm going to draw 5 lines. 1, 2, 3, 4, 5. Try to make them as even as possible. Alright, so now how many are going to go into each section? Well, how many plums are in each bag? 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And I like to draw my plums up and down and not in groups because I like how it matches my array. So see how it just looks like an array with lines drawn through it? Alright, if you can't make a bracket like our example, you can just draw a line and then draw a line and put like a little caret. Somehow my pen size got really big. Alright, now if you remember from our example above, this first part right here is just for this box. So this box has two different meanings. It means 3 plums, and it also means 1 bag. So what does the whole entire picture mean then? It means 18 plums and 6 bags. It's our total. It's our total plums and our total bags. And then don't forget to fill in that blank. There are 3 plums in each bag. Alright, let's move on to page 2. So we just have 3 more word problems on this one. And it looks like for each one we're going to, for the first 2 we have to do an array and a tape diagram. And the last one, it doesn't tell us, so we can decide. Problem 3. 14 shopping baskets are stacked equally in 7 piles. How many baskets are in each pile? Model the problem with both an array and a tape diagram. Show each column as the number of baskets in each pile. So again, the column is our size. It's the number of baskets in each pile. I know that there are 7 piles. So this is set up just like our last problem was. 7 piles. So 1, 2, 3, 4. Wow, those are getting really crooked, aren't they? Let's try again. 1, 2, 3, 4, 5, 6, 7. And I made my array smaller over on the side so I didn't have to move it again. 8, 9, 10, 11, 12, 13, 14. And that's all I needed. 14 shopping baskets, equally stacked in 7 piles. And then my columns, just to double check, are the number of baskets. It wouldn't make sense if I had 7 here because I have 7 piles, not 7 in each pile. So I actually have 2 in each pile. Now let's turn that into a tape diagram. Draw my rectangle. Don't forget to leave room to draw your brackets at the top and the bottom. And then now I need to divide up my tape diagram. Well, I had 7 piles, so I need 7 pieces. Do you remember how many lines I'm going to need? 1 fewer than the number of sections. So 7 sections, I need 6 lines. 1, 2, 3, 4, 5, 6. All right. 2 in each section. And why am I putting 2 in each section? Because I'm just recreating my array inside these boxes. There's 2 in each group, just like there's 2 in each group. What's my last step? Labeling. So, I'm going to draw my labels. I was going to try to move it, but... Alright, and let's label. This first section right here has 2 different meanings, remember? It is my 2 baskets and 1 pile. So then what is the total down at the bottom? 14 baskets, 7 piles. Alright, so we worked on those few examples together a lot. So I'm going to take a few more pauses on this next one so you can really try to work through this one on your own. But don't forget that I'll be here if you need me. So anytime you feel like you want to give it a try, just go ahead and hit pause and then you can hit play to see if your work matches mine. And if it doesn't, then all you have to do is rewind and go back and listen to my explanation. And then you can try to think about where you did your work and where it doesn't match mine. Problem number 4. In the back of the store, Mr. Prescott packs 24 bell peppers equally into 8 bags. How many bell peppers are in each bag? Model the problem with both an array and a labeled tape diagram. Show each column as the number of peppers in each bag. Okay, so I'll give you a hint. This is just like the 2 problems that we just did together. The size is the number in each bag, which is our columns, okay? So, like I said, hit pause, go ahead and give it a try on your own, and then you can come back by hitting play and see if your work matches mine. You can hit play and you can listen to my explanation and follow along, or you can fast forward a little bit, check your work, and if you got it right, then you don't need my explanation, or if you didn't get it right, then you can rewind and see where you went wrong. So hit pause now, give it a shot, and then you can come back whenever you're done. Alright, welcome back. So, how many bell peppers are in each bag? Well, let's draw our array first. I know that I have 24 peppers and they're in 8 bags, but my bags are not going to be my rows this time. My bags are going to be my columns. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 24 bell peppers, and I have 8 bags, and there are 3 in each bag. And I know my array is going the right direction because each column is the number of peppers in each bag. Now I'm going to turn that array into my tape diagram, giving myself enough room to draw my sections and make my labels. So I have 8 bags, means I need 8 sections. 7 lines will give me 8 sections. 1, 2, 3, 4, 5, 6, 7. And I'm going to draw my peppers just like I drew my array. 1, 2, 3, 1, 2, 3. And last, it's time for my labeling. So I'm going to label my top and my total at the bottom. Remember, each piece has 2 different meanings. So my meaning for this first section, just each section, I know that it is 3. So it is 3 peppers. And it's also 1 because it's 1 section, so it's 1 bag. So what's that mean for my total? Well, the whole thing is 24 peppers and 8 bags. How'd you do? Hopefully you did really well and you got many of the components to this array and tape diagram. Let's move on to number 5. Olga saves $2 a week to buy a toy car. The car costs $16. How many weeks will it take her to save enough to buy the toy? It doesn't tell us which method to use to solve this problem, so I'm going to show you both methods, an array and a tape diagram, in case you chose an array or in case you chose a tape diagram. So let's start off with the array. It doesn't tell me which is my groups or which is my number in each group, so let's think about it. If she's saving $2 each week, what goes into what? Does $2 go into the week, or does the week go into $2? Well, if she's saving $2 each week, then that means $2 is my size and week is my groups. And I'm going to keep going with the method that we've been practicing, where my size is my columns. So I know that I have $2 each week. So here's my first week, second week, third week, fourth, fifth, sixth, seventh, eighth. And I know, in counting by twos, 2, 4, 6, 8, 10, 12, 14, 16, that 2 times 8 is 16. Now let's draw our tape diagram. And remember, you don't have to do both methods, but it never hurts to practice. So I have 8 weeks. That means I need 7 lines to make 8 weeks. 1, 2, 3, 4, 5, 6, 7. And I'm going to put my 2 dots in each section, just like my array. Alright, now my last part is my labels. Label the top, label the bottom. $2 is what the 2 stands for, or 1 week. And then the bottom is $16. Remember, it's always my total, or 8 weeks. Thanks for hanging in there with me for Lesson 11 today about modeling division as the unknown factor in multiplication using arrays and tape diagrams. Don't forget to save your work so you can come back and look at it whenever you're doing your word work assignment.